Hello everyone. Here we will see delta to star and star to delta transformation. We will derive the formulas for both the transformation. Basically, these transformation used in circuit solution for making the equivalent resistance in Thevenin's and Norton's theorem, and these formula can be used in the circuit simplification where the circuit makes delta or star. For the circuit solution we can transform by these formulas and make the circuit solution easier. Now let's see the formula for delta to star transformation. For delta to star transformation, the point A, B and C that are making delta having resistance R1, R2 and R3, and it will be transformed into star from point A, B and C. The star resistances are RA, RB and RC. And the drive formula for delta to star transformation, for the value of RA, if you connect a resistance star resistance RA, it will be the R1 R3 divided by total resistance. And let's see the value of RB. RB is defined by R1 R2 multiplied divided by total resistance. If you see the value of RC, that is R2 R3 divided by total resistance. So these are the formulas for delta to star transformation, which will be derived in the coming slide. Let's derive formula for delta to star resistances. Here points A, B and C are making delta, and these are the star making points, and the resistances for delta circuit, that is R1, R2 and R3, and transform star circuit is RA, RB and RC. So let's derive the resistance RA, RB and RC. So if you see the delta structure here, the resistance between point A and B, that is RAB, you can see this RAB is R1 in parallel to R2 plus R3. So write RAB, that is R1 in parallel to R2 plus R3. So you can write it RA plus RB is equal to R1 R2 plus R3 divided by R1 plus R2 plus R3. So RA plus RB is equal to R1 R2 plus R1 R3 divided by R1 plus R2 plus R3. Now let's see the resistance between point B and C. These are the resistances between point B and C. Its value is R2 in parallel with R3 plus R1. So RBC is R2 in parallel with R1 plus R3. So you can write it RB plus RC is equal to R2 R1 plus R2 R3 divided by R1 plus R2 plus R3. Now let's see the resistance between point C and point A, that is RCA. These are the points. This RCA is R3 in parallel with R1 plus R2. So write the value of RCA. This RCA is R3 in parallel with R1 plus R2. So you can write it RC plus RA is equal to R3 R1 plus R3 R2 divided by R1 plus R2 plus R3. So here we see the equivalents between points AB, BC and CA. So this is our equation 1 and this is our equation 2 and this is our equation 3. Now add equation 1, 2 and 3. If you see the left side of these equations, that is RA plus RB, RB plus RC and RC plus RA. So you can write it 2 times RA plus RB plus RC. If you see the right side of these equation, R1 plus R2 plus R3 are the taking as LCM, and you see the numerator, that is R1 R2 R1 R3 R2 R1 R2 R3 R3 R1 and R3 R2, that is 2 times R1 R2. You can see this is 2 times R1 R2, 2 times R1 R3 and 2 times R2 R3. So our right side equation is 2 times R1 R2 plus R2 R3 plus R3 R1 divided by R1 plus R2 plus R3. This 2 will be cancelled out. So our equation will be RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1 plus R2 plus R3. This is our equation 4. If you see this equation 4, you can derive RA, RB and RC directly. So if you subtract equation 4 minus 2, you will get RA from the left side. You will subtract 4 minus 3, then you will get RB, and if you subtract 4 minus 1, then you will get RC. So let's derive, that is for RA you will subtract 4 minus 2, and for RB you will subtract 4 minus 3, and for RC that is 4 minus 1. Now let's see the equations. If you see the 4 minus 2 from the left side, 4 minus 2 you will get RA. So let's see the equations. This is equation 4, this is our equation 2. From the left side we get RA, and from right side R2 R1 R2 R3 will be subtracted, these two values, so you will get R3 R1 divided by R1 plus R2 plus R3. So this is R3 R1 divided by R1 plus R2 plus R3, and you can see 4 minus 3. If you see the 4 minus 3, you will get RB from left side, and from right side R3 R1 and R3 R2 are subtracted. This is R3 R1, this is R3 R2 that are subtracted, you are getting R1 R2. So for the value of RB, this RB is R1 R2 divided by R1 plus R2 plus R3. Now if you see the value of last equation, that is 4 minus 1, 4 minus 1, you can see from the left hand side you will get RC, and right hand side R1 R2 R1 R3 are subtracted these and this, so you will get R2 R3. So the value of RC, that is R2 R3 divided by R1 plus R2 plus R3. So these are the formulas for delta to star transformation. Now see the formula for star to delta transformation. Point A, B and C are making star and delta. Our star resistances are RA, RB and RC, and transform delta resistances are R1, R2 and R3. Now let's see the values. The resistance between point A and point B, that is R1 for delta, that is RA-RB plus RB-RC plus RC-RA divided by opposite point resistance RC. Here you can derive R1 is equal to RA-RB divided by RC plus RB plus RA. Now see the resistance between point B and C, that is R2. R2 is RA-RB plus RB-RC plus RC-RA divided by remaining point resistance, that is RA. Now you can derive it. R2 is resistance between point B and C, so this is RB plus RC plus RB-RC divided by RA. Now see the resistance R3, that is points between point C and A, that is RA-RB plus RB-RC plus RC-RA divided by remaining point resistance RB. So here you can derive R3 is the resistance between point A and C, that is RA plus RC plus RC-RA divided by RB. So these are the formulas for star to delta transformation. Now derive formula for star to delta transformation. Point A, B and C making star and delta, and here RA, RB, RC are star resistances and R1, R2, R3 are our delta resistances. As we discussed earlier, the delta resistances, that is R1, R2, R3, when it transform into star, so the calculated values of RA, RB, RC, we know these values are taken as a base equation for the derivation. So these base equations, that is RA, as we discussed earlier, that is R1 R3 divided by R1 plus R2 plus R3, and here the RB is R1 R2 divided by R1 plus R2 plus R3, and the value of RC is R2 R3 divided by R1 plus R2 plus R3. So these are our base equation. These equations used for the derivation, we are assuming this is our equation 1, this is our equation 2, and this is our equation 3. So for the derivation purpose, we will multiply 1 into 2, then add, multiply 2 into 3, then add, and multiply 3 into 1. Now see on the left side, if you see for 1 into 2, so here this is 1 into 2, you will get RA-RB, and 2 into 3 RB-RC, 3 into 1 RC-RA. So write the left side of equation, that is RARB plus RBRC plus RCRA. Now let's see on the right side of equation. If you see 1 into 2, you will get R1 square R2 R3 divided by R1 plus R2 plus R3 whole square. So 1 into 2, you will get R1 square R2 R3 divided by R1 plus R2 plus R3 whole square. Now see 2 into 3. If you see 2 into 3, you will get R1 R2 square into R3 divided by R1 plus R2 plus R3 whole square. So here you will get R1 R2 square R3 divided by R1 plus R2 plus R3 whole square. Now let's see the value of 3 into 1. If you see 3 into 1, you will get R1 R2 into R3 square divided by R1 plus R2 plus R3 whole square. So here we get R1 R2 R3 square divided by R1 plus R2 plus R3 whole square. So here we can write RARB plus RBRC plus RCRA. If you take LCM, that is R1 plus R2 plus R3 whole square, and in the numerator R1 square R2 R3 plus R1 R2 square R3 plus R1 R2 R3 square. Now here RARB plus RBRC plus RCRA is equal to, now this is R1 plus R2 plus R3 whole square. You can take R1, R2 and R3 as a common quantity. Here we get R1 plus R2 plus R3. This R1, R2, R3 will be cancelled out. Now here we get RARB plus RBRC plus RCRA is equal to R1 R2 R3 divided by R1 plus R2 plus R3. This is our equation 4. Here we get equation 1, 2, 3 and 4. So for the derivation of R1, R2 and R3, we will see the 4 divided by 1. If you see the equation 4 divided by equation 1, you can see on the right hand side, equation 4 divided by equation 1, you will get the value of R2, and here you will get the value of R2, and if you divide equation 4 by equation 2, then you will get the value of R3. You can see 4 divided by 2, you will get the value of R3, and if you divide equation 4 by equation 3, then you will get the value of R1. So let's see the values. First we discuss equation 4 divided by equation 3 for the value of R1. So here now see the equation 4 divided by equation 3. R1, R2, R3 will be cancelled out, and R1, R2, R3 divided by R2, R3, R3 you will get R1, and from the left hand side you will get this RC is divided, so you will get the values R1 is equal to RA divided by RC plus RB plus RA. This is the formula for R1. Now you can say for the R2, equation 4 is divided by equation 1. Now you will get R2 for the formula. Now you can see 4 is divided by 1, you will get R2, and this RA divided by this equation 4. So you will get this is RB plus RC divided by RA plus RA. Now let's see our last equation, that is 4 divided by 2. Now let's see the equation 4 divided by 2. You can see from the left hand side, that is RB is divided by this equation, and right hand side you will get R3. So our equation is R3 is equal to RB will be divided in the equation 4. So it is RA plus RC plus RCRA divided by RB. So these are the formulas for R1, R2 and R3 from star to delta resistances. So here star resistances as RA, RB and RC are given. So our transform delta will be calculated by resistance R1, R2, R3 by given formula. Thank you for watching the concept. Please like and subscribe my channel.